Hello. Today, we're going to talk about how galaxies emerged in the vast expanse of the universe. How did these majestic structures form out of primordial chaos? What brings billions of stars, gas, dust, and dark matter together into organized systems? Let's embark on an exciting journey through time and discover how cosmic order is born from chaos. Let's get started. When we look at the night sky, we see billions of stars gathered into enormous structures called galaxies. Each galaxy is a complex and orderly system composed of stars, gas, dust, planets, and dark matter. But have you ever wondered how these majestic cosmic formations emerged from the primordial chaos of the early universe? This process is incredibly intricate and spans billions of years, beginning with the moment of the Big Bang. To understand how chaos gave birth to cosmic order, we need to travel back in time to when the universe was young, hot, and chaotic. Approximately 13.8 billion years ago, the Big Bang occurred, marking the beginning of the universe. At that moment, all matter and energy that we observe today were concentrated in a single point of infinite density and temperature. It was a state of absolute chaos, with no stars, galaxies, or even atoms. The universe expanded at an incredible rate, and in the first fractions of a second, the inflationary epoch began, during which space expanded trillions of times in size. After inflation, the universe was a hot plasma filled with elementary particles such as quarks, gluons, and leptons. Gradually, as it cooled, these particles began to combine, forming protons and neutrons. About 3 minutes after the Big Bang, nucleosynthesis began, creating the first atomic nuclei of hydrogen and helium. However, despite these early steps toward order, the universe remained largely homogeneous, without any significant structures. Although the early universe appeared uniform, small quantum fluctuations in density, tiny variations in the distribution of matter, existed. These fluctuations became the seeds from which galaxies eventually formed. In regions where matter density was slightly higher, gravity began pulling and surrounding gas, dust, and dark matter, creating zones of increased concentration. Dark matter, which accounts for about 27% of the universe's mass energy, played a critical role in this process. Although invisible and undetectable by traditional means, its gravitational influence provided the framework for the formation of the first structures in the universe. Without dark matter, the process of galaxy formation would have been impossible or significantly slower. Gravity became the primary architect of galaxy formation. In regions of increased density, enormous clouds of gas and dust began to form. These clouds, under the influence of gravity, compressed and became denser and hotter. Within them, regions emerged where pressure and temperature reached critical levels necessary for nuclear fusion. This marked the birth of the first stars. These stars, known as population 3 stars, were massive, bright, and hot. They consisted exclusively of hydrogen and helium, as heavier elements did not yet exist. However, such stars had short lifespans, only a few million years. They ended their lives in powerful supernova explosions, enriching the surrounding space with heavy elements like carbon, oxygen, and iron. These elements became the building blocks for subsequent generations of stars, planets, and even life. The first galaxies began forming around 400 million years after the Big Bang. They were small, chaotic structures filled with young stars and gas. These proto-galaxies collided and merged with each other, creating larger formations. The process of merging was crucial for galaxy evolution, as it redistributed matter and increased their mass. The shape of a galaxy largely depended on initial conditions, its rotation speed, the amount of gas, and interactions with other galaxies. This is how various types of galaxies emerged: spiral, elliptical, and irregular. At the center of most galaxies lie supermassive black holes, with masses reaching billions of solar masses. These black holes play a key role in galaxy formation and evolution. They influence star formation by emitting powerful energy outflows that can either stimulate or suppress the birth of new stars. For instance, in active galaxies like quasars, black holes consume enormous amounts of matter, accompanied by the release of colossal energy. These outflows can heat surrounding gas, preventing its compression and, consequently, the formation of new stars. Today, scientists use powerful telescopes like Hubble and James Webb to study galaxies at different stages of their evolution. These instruments allow us to peer into the most distant corners of the universe, observing light that has traveled billions of years to reach us. Thanks to these observations, we can study how the first galaxies looked and how they changed over time. The process of galaxy formation is a fascinating story that begins with chaos and ends with the creation of orderly structures filled with stars, planets, and possibly life. Studying galaxies not only helps us understand the origin of the universe, but also brings us closer to understanding our place in this vast cosmos. When we gaze at the stars, we see not just their light, but also the story of their birth, evolution, and death, a story that continues to unfold today. Thank you for joining us on this amazing journey through the history of galaxy formation. The universe is an endless source of mysteries, and we are just beginning to uncover its secrets. If you enjoyed this, don't forget to share your thoughts and questions. There's plenty more exciting topics ahead. See you in the next episode, and remember, our cosmos is as limitless as our desire to understand it.